Let's take another look at dividing fractions. This time, instead of just going with the algorithm, we want to look at being able to model that, draw a pictorial representation of that. So we have 4 divided by 1/5. Okay? Whatever that means, we need to look at 4 wholes is what I have. That's the dividend. That never changes because that's what I have. I have 4 wholes of something, whether it be bags of Tootsie Rolls, whether it be pies, whether it be desks full of mess. Okay, since I'm in the classroom, you know, real life problem right there. Anyway, 4 divided by 1/5. A great way to ask that is taking this, how many 1/5 are there in 4 wholes? Okay, that's a great way to ask that question. 4 divided by 1/5. Yeah, so how many 1/5 can you get there? Let's look at the algorithm and then we'll look at a modeling of it. Okay, 4 divided by 1/5. The dividing by fractions principle is to divide by fractions you can multiply by the reciprocal. Okay, so 4, we have 4 wholes here. Multiply by the reciprocal. 1/5, we just don't like dividing by fractions. Okay, 1/5, the reciprocal, okay, 1/5 is simply the opposite, 5/1. Okay. Now because I did the opposite of one part, 1/5, I did its reciprocal, I need to do the opposite of something else. I can't change the whole, what I brought to it, so I do the opposite, or the inverse operation of dividing. So that's an algebraic principle. You can multiply by the reciprocal and it will stay the same. Okay? Now that I have this, oh, it looks like we're multiplying fractions, so I need to simply divide this by 1 whole because any number in the world divided by 1 is still the same. And then we just have a multiplying fractions. 4 times 5 equals 20, 1 times 1 equals 1, any number divided by 1 equals itself, so we have 20. That's how to do the algorithm. Multiply by the reciprocal. Leave the first number the same. Okay, now, as we're asking how many fifths are there in 4, well, let's draw it out. We have a model here. Apparently I'm going with circles. Okay, so how many fifths are there in 4? If I'm asking how many fifths, I need to divide each whole by fifths. Okay, so let's divide by fifths. Oh yes, this is a beautiful division. Everything is exactly equal, just like fractions should be. Probably shouldn't have chosen fifths, but that works. Okay, so I have divided each whole number into fifths. Now I'm just asking how many fifths are there in 4 wholes. So we just 5, 10, 15, 20 fifths in 4 wholes. We got that by doing the algorithm, and we are also able to model that by asking the question, how many fifths are in 4? Hope that helps. Modeling fractions. Modeling dividing fractions.